Okay, so before we jump into the example, we should take note about some of the formulas that we need to use, like this one. This is the most important formula that we will be applying throughout the whole process of power unit method. And there are 4 other formulas that we need to take note about. For example, this one, like we are converting the 3-phase voltage into single phase and 3-phase power into single phase power, and the voltage, which is the base, will be calculated through this is the transformer ratio, and the impedance base will be calculated with this formula. But we should note that this is the most important formula that we need to remember. Okay, so let's get back to the problem that we were supposed to solve. Now we have to take note that the given system power base is equal to 100 MVA and the voltage base is 33 kilovolt. So our S base will be 100 MVA and V base 1 will be 33 kV. Okay, so now we'll be proceeding with the generators first. For example, this is the generator 1, and as I have mentioned that we will be using this formula. So according to this formula, we will be calculating the Z base per unit. So 0.12, which is this reactance equal to 12%. So 0.12 into the S base nu. So the S base nu, I have told you that it was 100 as was the given in the question, like 100 by 3, because we are converting it into single phase. And the old S base, which is this one, 100 MV. So this is here, into V base old. V base old means that this 30 kilovolt, and we are again converting it into single phase. So V base old by V base new. And as I have said that in the question, it was given that V base new is 33 kV. So if we do the calculation, it will be 0.1 per unit. Now the same application will be taken in the generator 2, like the same formula, and this time 0.15, which came from this one, 15%, into S base new, which was the 100 MVA, and the 80, which is this one, 80 MVA. And you can already understand what's going on in here, that this is the V base old, which is 25 kV, and the V base new is 33 kV. So do the math and you will get Z base per unit equal to 0.107 per unit. Now this is for the generator 2. See, we already got the 2 per unit impedances for the generators. Now let's move on to the transformer side, like this one. How do we do that? We'll be applying the same formula in here as well, like 0.15, this is the 15%, into the S base new, which was 100 MVA, by this 200 MVA, which is the old S base, into V base old, which is like this 20, as you can see, okay, by the 33 kV, which is the V base new. So do the math and you will get the impedance in per unit equal to 0.027 pu. So we are done with the transformer 1. As for the transmission line, as I have said about one formula, that V base 2 equals to V base 1 into the transformer ratio. Now the V base 1 was given in the question, 33 kilovolt, into the transformer ratio, which is this ratio, as you can see, okay. And if you solve this problem, you will get V base 2 equals to 247.5 kilovolt. Okay, so there was this another formula, Z base equal to V base square by S base, and then just plug in the value of this into this. Now I am dividing this with √3 because we are converting it into single phase. And then there will be S base, which is 100, into I mean, you have seen that in the question it was 100 MVA, which was the S base nu divided by 3. We are also converting it into single phase. That's why we're dividing by 3 and this root 3. And if we do the math, you will get the Z base equal to 612.56 ohm. Now, these data are to be applied in this formula, like X actual, which is the reactance, the actual reactance of the transmission line, 80 kilometers into 0.4 ohm, and if we multiply it, we will get the actual reactance equal to 32 ohm. Now we all know that the per unit reactance is equal to actual reactance divided by base impedance. So if we plug in the values like the 32 ohm and this Z base into this one, then we will be getting 0.052 per unit to be the value of this one, the per unit reactance. So this is the transmission line per unit value. As for the transformer 2, we'll be applying that same formula in this case as well, the 20%, which means that 0.2 into S base new divided by S base old into V base old divided by V base new whole square. I mean, this V base, you might be wondering where it came from. It's actually came from this one, V base 2, okay, the new V base. And then we have to apply the this formula, and then we'll get the Z base per unit equal to 0.316 per unit. Now 220, actually it comes from this one, this 220 from the transmission side, and if you do the math, you get Z base per unit equal to 0.316 pu. So finally we have reached the motor part, and this time the same formula, but just take a look that V base 3 equals to V base 2 into the transformer ratio. Now V base 2, we got this 247.5 was equal to V base 2, and the transformer ratio is this one, like 15 by 220. So just plug in the values and you will get the V base 3 16.875 kilovolt for the motor. Now this is the new V base for the motor side. So now we'll be applying that formula for that impedance, like Z base per unit equals to 0.25, this 25% in here, into S base new by S base old, this 10 MVA is the S base old, into the V base old, which is like 11 kV, divided by the V base new, which is this one, 16.875 kilovolt. So just do the math and you will get Z base pu equals to 1.06 per unit. So this is the base impedance for this motor side. Now we have done all the calculations we needed to do in order to find the impedances in per unit. So now we finally can build the actual per unit diagram, which will look like this. Take a look that there's two generators like this one, and I've just put the values we just calculated so far. For the generator 1, we found that J 0.1 per unit and 0.107. I mean, just plug it in the diagram like this, and this is the ultimate per unit diagram. So we finally succeeded in converting this whole power system into the per unit diagram, which is this one. It's pretty easy and it's time saving as well. So I hope you understand how to apply per unit theorem in order to convert any power system into a per unit diagram like this. If you have any question, let me know in the comment section, and don't forget to subscribe to my channel.